So welcome to the next episode of creating our text adventure game in 3 languages. Now, the first thing we're going to do is to draw some kind of plan as to what's involved in our game. So if we start with what I drew originally for the game that I demonstrated on the first video of this series, it was just a simple set 4 rooms. The starting place was a hotel room, and inside there was a key, and then it had a door to the east, and that door led to a corridor, and inside the corridor was a torch. The door is two-way here, but to get back in you needed to have a key card. So that was an essential item that you would need. The room above was a magic portal. And that was the end game. And that had a door one way, so that you could go from the corridor into the magic portal. Then of course the game finished, so that's effectively one way. But this door needed a dragon heart to get in. The final one was a lift, or if you're in the US, an elevator, and inside there were no items, but there was an enemy, which was a dragon. And the dragon contained the dragon heart. So obviously you had to kill the dragon to get the heart, which you could then use to go through to the magic portal. So the key is an item, the torch is an item, the dragon is an enemy, the dragon heart is also an item. There was a door again, two-way between the two. So that's the layout of our very, very simple game. Just those 4 rooms, the doors in between them, and any items that they were carrying. The only thing I haven't mentioned, of course, is that there was the player. So the player would also have its own set of items and properties and so on, so that the player would have a name, a description, and maybe 1 or 2 other things as well. But more importantly, the player would have to have somewhere an inventory and an item that's held in the player's hand. So I'll call that item in hand, and in this case it was the room key card, as you'd get on a modern hotel. So we've got the name, maybe age group, maybe health, strength, and maybe the character that your player was. So in a traditional adventure game it would be sort of mage or fighter or magician or whatever you wanted to call it. So that was the kind of character. Now I would keep mentioning items, so items would be another sort of construction that we need to make here. And again, the item would have a name, maybe a description, maybe that it was able to inflict damage on an enemy, so we'll put it damage. So for example, you could have a sword which gave out 100 damage, and you could have the key which gave out 10 if you used it on your dragon. So you can obviously set that up to suit. Then we'll want an enemy, and again there's various things about the enemy that you would need to know, like its name, description, and so on. We also what the item dropped when the enemy is killed. So you can see how these things are all kind of linking up. You've got the player has got an item in, or items in the inventory. There's an item in his hand. The enemy maybe has an item inside it. The room may have an enemy in it. The room may have items in it. So these things are all kind of linked up. So programming this is going to be pretty tricky if you're just using a bunch of simple variables in your descriptions and so on. It's going to get horrendously difficult. So we really need to kind of have a better way to store all this stuff. So what would be nice if you could have, for example, the player here as some kind of super variable, so that everything about the player was all held inside this super variable. So that's what we're going to be looking at next. So I'll just save this page, that's fine, and we can refer back to that as and when we need it. So what I want you to do is, if you're following along with this, if you've got a folder where you're going to store your game, I've just put this one in a USB drive, which and I've made a little folder called Scratchpad. So this will be for my where I'm going to store everything. So we want a new file. I'm not doing this from an IDE. This is going to be done in Notepad++. So we're just going to call this one player.py. So we'll delete the text bit. Of course, when I press enter, Windows will complain, but that's okay, that's what we want. And let's have another one. New text document, and we'll call this one program, simply because the C# equivalent of this is called program by default, and so it would be kind of nice just to keep that consistency. So we'll call this one program py, and there we go. So you've got these two files that you're going to run your game from, the program one and the player one. Now I've got a set already running here. Let me just drag this out. So this is not in the folder I've just created, because obviously these are empty, but in another folder. I just wanted to show you how you can easily create your own files outside of an IDE just in Windows Explorer by just renaming a text file. So we've now got a player file, and inside it, as you can see, there are just five simple variables. The name, which I've called player, age group 0, character empty string, health 0, and strength 0. Now this is saved purely with everything. There's no actual code in there apart from these 4 or 5 variables. So put those in, save it. Of course you can change the names of these and what they contain, that's completely up to you. And then we'll go to the program.py, which I've already written out because it's quicker than you watching me typing and making mistakes and making a complete fool of myself. But the important thing you'll notice here is this line here, import player. This is not some pre-made library that exists in the Python repository. This is your file here. So it's very important that the spelling and the case of this is exactly as you've got it here. Mine is with a capital P, player.py. You don't put the .py bit in, but you must have the capital P. So we're importing our own library. So we've just made a library here, and all it's got in it is these 5 variables. Then we've got, of course, because we want to copy the C# way of doing things, we've got a main function, def main, and all it does is to print the player dot name. So this may be something you're familiar with already, or this may be new to you, but because we're importing our own function, we can get bits of this, we can get the relevant parts of this by using these variable names inside it. So by using this dot syntax here. So my first line will print out the player dot name. Then we've got player dot name equals Fred, but over here it says the name is player. So what we're doing is we're effectively reassigning the original value as given player. We're reassigning it with a new value, Fred, and then we're going to print it out again. So let's just make sure this works. Let's run it with Python. There we go. I'll just trim that down a little bit so that we can move it about. So print player.name, and the name was player. Just shrink this a bit so we got them both of them online at the same time. Then we changed the player name to Fred, and then we printed out the player.name, which has now of course been changed to Fred. So you can see now how the player here that we've set up, that's got all these characteristics, the name, description, health, whatever, is all being represented now by, if we just move that back out of the way, by these variables here. So the name, age group, character, health and strength. So we've kind of done exactly what I thought was a good idea, that we could have some kind of super variable that could hold all of this stuff. Now this isn't going to work exactly the same for item because we've only got one player. So if we did the same thing and tried to make a super variable for item, if we only had one item that would work, but we need multiple items, so that's not going to work. We'll come on to that later, but what we've effectively done here in Python is we've created a static class. I'll explain a bit more what a static class is. Now this is not got the word class in it anywhere, which if you've already studied this sort of thing you think, yeah, how can that be a static class? It doesn't have the word class, but we've kind of got the bare minimum by making a separate module with only those things in it. This module is acting like a static class, so we can't make multiple instances of it. We can't make another player and use all this stuff, because every time you change it, it changes it for all instances, so that's not going to be very helpful. But for our single player, this is really good. So as you can see with the output here, we can make changes to the static class by calling it directly using the dot notation, and that works really well. So I just want to show you now the exact same process in Lua. So we'll move over to the Lua. I'll just magnify the text a little bit there. Now Lua is slightly different. We can still do the same thing. We've got a player.lua file, and all we're going to put in it is the player's characteristics. But Lua does not have lists, dictionaries, arrays, all the stuff that you expect from Python. It only has a table. That's the only structure that Lua has. You might think, well, that's a bit of a waste of time, but that table acts as and can act like any of the other structures found in any other programming language, including you can make objects, classes, inheritance. The whole works is all available in Lua by using the table, but we'll come back to that as and when. So in Lua, what we do is we create a variable called player and we set it to an empty table. The word local I will come back to a little later. We're going to go into variable scope, but for the time being, this is generally used in Lua local against pretty much every variable that you declare. So that makes this variable local to this script. It can't be seen outside of the script. And we make it equal to an empty table. Then there's two ways of creating elements inside this table. The first one is this one here, which is similar to what you might use in Python with a dictionary. So you've got the open square brackets, and then the index is this time a string, which in this case is name with a capital M, is equal to player. But the other way of doing it is to use the very same dot notation that we used a little while ago in Python. So either of these work perfectly. I could easily have put square brackets around age group, but it looks kind of neat to put player dot age group equals 0, player dot character, and so on. The only difference here is that we have to return this table back to whatever's calling it. So it is a little bit different, but it works in a very similar way. Now the main Lua program, in Python, in our program, we had import player, which means find the library called player.py and bring it in and I'll use it. And then that's exactly what you do. In program, it's similar, but you have to declare a variable. Again, this should be local. It works without it, but just to keep consistent, that should be a local player equals require, which is the same as input player. Again, it has to be spelt with the proper case, so it's capital P, and you don't put .lua, so you require the player. Again, we've got a main function, and this is it, and again it's printing out player.name, and then player.name is Fred, we're changing it, and then print player.name so that we should see the new version. Now the reason for these bits at the bottom is because I've now required another file, I can't get this to run properly in Lua. It comes up with errors. So the only way to run it now is to double click on the finished Lua file. So let's go back. Here it is. So this is my program.lua here, and this is my player.lua. So let's see if we can get this to run. Good, it's actually appeared on the other screen, so we'll just drag that across. There we go. Get this one out of the way. So we've got in the main function print the player.name, which of course was player, and then we want to change the player name to Fred and then reprint player.name. So it started off as player, it changed to Fred, and then it says press enter to quit, and then IO read. If I didn't put that in, what would happen is that this window here would pop up and disappear immediately, because there would be nothing to stop it from disappearing, which it's just done. So that's why I've done that there. So let's come back to this one, and we'll do the same with C#. So player CS. Now this is a slightly different version to what you would do if you were actually running this inside the IDE, such as Sharp Develop or Visual Studio. We've got an actual declaration here that tells you that this is a static class called player and that it's public. In other words, we can access this class from our program.cs. Similarly, we've got the variables here, but we can't initialize, that is, we can't give them I can't go like equals player, because the compiler won't allow it and you'll get errors before you even try and run it. So you can declare them as variables that are being there, but you can't give them a default value. So you just have to declare your 5 variables. Now here we've got the word static again, because this is a static class. And then we've got the types of variables: string, integer, string, and again integers. They are given a default value, but the default value for the strings is null, so it's not really that helpful. So with the using a static class, you have to sort of get it going when you first create it. Then you can give these variables an actual value. So this here is important. This is not good practice. When you're dealing with proper classes, you do not normally allow yourself to access these variables directly. So this is poor programming practice, but it fits in with what we're doing in both Lua and Python. Now program CS itself, again, I've had to use this because we're running it in a script. So this is to be the last demonstration I give of writing C# code in Notepad++ as a comparison. From now on we'll be using the IDEs because it's just getting too complicated, but I have to load in player.cs very much like I did with the Python and Lua. This is the Lua require, and of course this was the Python import. So we're loading player CS, then the main function. This time I've got to initialize this class to give them some actual values. Then I can print out the player name. I can then change the player name, again write out the player name that's now been changed, and finally, as with our Lua, we've got to stop the console from disappearing. So let me just run that with C#. It's compiling for a second. There we are. So simple as that. It works perfectly. Just close that up. So when we ran our main, the first thing it did was to initialize the player class and then wrote the player's name, which was set to player by default, and then it changed it to Fred and wrote the player's name again. So this is also working exactly the same way as both our Python and Lua equivalents. So I think that will do for the moment, and we'll move on next to getting this idea of the scope of variables, which this where we're using public and private and local and all that sort of thing. So we'll show you that next off.